All right, guys, today we're adding and subtracting them again, but we're going to do them with harder problems. Way harder problems. Let's review a little bit from yesterday, just get our bearings. Can you add those two guys together? Jessica, why not? What do you have to have in order to add two fractions? Yeah, we got to find the least common multiple of the denominators. We got to have common denominators in order to add them. So what is the LCM of these two fractions? 4x, nice. So I'm going to multiply this one by 4 over 4, and I'm going to multiply this one by x over x. And so you distribute that inside, you get 4x plus 16 over 4x plus 4x minus, not 4x, plus x squared minus 4x over 4x. Yeah? And then equals, and then we're going to, combine them, so it's going to be like x squared plus 16 all over 4x. Yep. That's that one. You good? Those are easy. Okay. So now the bottoms are vastly different. Vastly different. Let's watch for a minute. Let's watch for a minute. Suppose you're given this. Some people in here know the trick. I'm going to rotate this one on the left around. So it's going to be negative 3 plus x over 3 minus x. Okay? That's step one. All I did is take this one and I rotated it around. I didn't do anything else. I know it's nope, just all I'm trying to do is just kind of reorganize a little bit, try and figure out what I could possibly do, how I can make them the same. Okay, so there's that step. There's that step. The next step I'm going to do is, and today is all going to be about factoring, I'm going to factor out a negative 1. You're allowed to do that with these problems. Now, if you want to, at a certain point, you can take a shortcut when you see these kinds. But for right now, we're taking the long route. Now, right? I didn't do anything, really. All I did was take the bottom of the first one and reorganize it around. You could have taken the bottom of the second one also as well. How are those two different? Yeah, one has a negative 1 times 3 minus x. The other one's missing that. So what are you going to multiply that second one by? Negative 1, just as Carly said in the beginning. We're going to multiply top, and we're going to multiply the bottom by negative 1. Now, on the top, I'm actually going to multiply the negative 1 in, but on the bottom, I'm not going to. Well, because it doesn't really do anything. Yeah, the bottom I'm not going to be adding or subtracting anyway. I just needed for them to be the same. So it doesn't help. You could if you wanted to. I'm also going to write it out of order like that. You know why? Because somebody always asks, what does it have to be in that order? What happens if mine are out of order? What property allows me to write things out of order like this? Yeah, commutative. Very nice. That's why we learn about all those properties. And so now look at what we got. We got 3 minus x over negative 1, 3 minus x. Oh. What's up? Yeah, we're going to cancel it. Right, they cancel out to being 1. So here we go. Right, from here, the answer you could say is this. That's the same thing as this. Doesn't make a difference. Let's go back up to the top. There's our answer. Up. Guys, what is the LCM of this fraction? What's the least common multiple of the denominators? The least common multiple of these two denominators, the least common denominator is x times x plus 3. You see that? This one we're going to multiply by x plus 3 over x plus 3. Guess what we're going to multiply the other one by? By x over x. What do you mean? What happened? You okay with that?
Yes.
Okay. Nice. So then you get 2x, oh, it got corrupted. You get 2x over, and like I said, I wouldn't multiply the bottoms in because you want to see it in its factored form just in case you're going to break stuff down later on. Hopefully maybe that'll occur here. You'll understand what I'm talking about. Right? There we go.
Wait, I have a question.
Sure.
Do all these multiply the denominators like the opposite side?
Pretty much, yeah. That'll be a rule. The least common, a common denominator will always be the multiples of all the denominators. It just might not necessarily be the smallest. And in some instances, they can get really out of hand, which is why you want to find the least. But you could always do that. Okay, so what do we got next? We got 3x plus 3 over x plus 3. Oh, good. You're going to see why it is that I didn't multiply the bottoms out. Why didn't I multiply them? What do you do next? Nope. Don't multiply the bottoms in. What's up? You can't cross out the 3's. You want to factor so you can see if anything reduces. Let's break down the top a little bit. Bless you. Aw, damn. Nothing matched. Shoot. You can't cancel anything. So that's the final answer. But there are a lot of instances where you get to this step over here and you think you're done, and actually there's one more step where the last point is awarded, and that's for factoring things out and reducing. That's why you don't want to multiply those bottom numbers in, because why multiply them in only to have to refactor later on? Just leave them like that. Just leave them like that. Oh, yeah. I mean, this is what I personally do. And if you were going to try and see which one is the answer, which one is the answer?
D.
I think it's D. So because it would be 3x plus 3 and then x squared plus 3x. Yeah, it's D. Okay, good. It's this one right here. That was 5. Oh boy. Let's step our game up another notch. Let's go to 8. What? That's bad. Not gonna lie, that's really bad. If you're faced with a problem like this, the first thing that you want to do, and the first point that gets awarded, is for you knowing that you should try and factor the bottoms so that you can begin to figure out what the common denominator should be. Oh, that wasn't that bad. Take a look, all right? All I really did was, I noticed that that was the difference of 2 squares. Bless you. Now, very nice. That's all you got to do is multiply the second one by h plus 4, because that's what it's missing. That's what it needs so that it can be combined with the other. All right. That's easy. Wish I had my staples button. That's easy. H plus 4, h minus 4 plus is going to be 2h plus 8 over h plus 4, h minus 4. Whoops. What's up? You go that route. Let's see what happens. I'm going to get 3h. Negative 20 plus 8 is how much? So some people wanted to distribute the stuff in the bottom because they didn't want to write this out. Ah, we must be done, right? No, of course not. Of course not. Because you see the top can be factored. That's 3 times h minus 4. And so this is why you don't want to multiply the two bottoms. You see, if you multiplied the two bottoms, it was kind of like a waste of it was a waste of a step. Those two cancel away. Yeah. All right, we're on 29. So this one over here we're going to multiply by, yep, you are correct, x minus 1, my bad. And this one over here we're going to multiply by x plus 1. And the result, we're going to get 3x minus 3 over x minus 1, x plus 1. Tell me. Over here, we're going to get 2x plus 2 over x minus 1, x plus 1. Oh, I'm going to distribute the negative afterwards. Just the bottoms, the tops, you need to combine them all. And then once they've been combined, they will factor differently than when you break them up into their parts. Okay, originally. So yeah, so here we go. Now raise your hand if you like me writing everything out, or writing everything out. Like, tell me if you understand this. 3x minus 2x is how much? You get that? And what about negative 3 minus 2? Go. Okay, so so the top is just going to be x minus 5 over x minus 1, x plus 1. If you don't understand that, I'll write it out the long way. Olda. You could, but it would factor back into this up over here. You need to combine them. Oh my God. Sorry about that. There. Oh, maybe I made a mistake. Let's take a look. Let's go the long. Whoa, whoa, whoa. Let's go the long route. Let's go the long route. The top, because some people get pissed off when I show out all my work. Actually, they get just really bored. The top, the first one is 3x minus 3, right? The next one is we need to subtract away from it 2x plus 2. Does that make sense? All right. So then really here's what we have. We have 3x minus 3. This negative gets distributed inside. And it's like, whoa, I don't need parentheses around it. Let me take the rubber band off of it. 3x minus 3 minus 2x minus 2. All over x minus 1, x plus 1. 3x minus 2x is x. Negative 3 minus 2 is negative 5. So it's the same thing, but sometimes you can lose track of things like that. Yeah?